Hello students, today we'll be doing a problem based on Alembert principle. Now what does problem says? A body of mass 25 kg resting on a horizontal table connected by a string passing over smooth pulley at the edge of table to another body of 3.75 kg mass and hanging vertically. Initially, the friction between 25 kg mass and the table is just sufficient to prevent the motion. If an additional 1.25 kg is added to the 3.75 kg mass, find the acceleration of the masses. Now, this is the diagram which is being provided along with the question. The red mark is not being there, only the blue marking. So there is a block which is of 25 kg and the hanging block which is 3.75 kg. The pulley is frictionless. Now we have to find out the frictional coefficient, or we can say coefficient of friction first. So for that, what we'll do is we'll apply a static equilibrium analysis. Static equilibrium analysis says that the block A is under condition when it is about to move, as it is mentioned that initially the friction between table is just sufficient to prevent the motion. So here static equilibrium for this particular block, if I draw the FBD, there is a tension away from the body, away from the pulley, same tension away from the pulley, away from the body, or a block T. So if I'll talk about FBD of a block A, in that T away from the body, the weight of the body is acting downward direction. Towards the body, there is a normal force acting, and as the body is moving right side, the friction is moving left side. Now the question comes, how we got to know that this body is moving on a right side? As this body is having a lesser value, still this body is moving on a right side. How is it possible? Now tell me one of the case when this body will move this side. Is there is any possibility? There is no possibility that block A will move this side. That's why we are considering only one case where the block A is moving on a right side. For that, we have taken friction in the opposite direction. So if I'll apply a summation f of y equals to 0 upward direction positive, with that minus WA downward direction plus N1 upward direction equals to 0. N1 equals to WA. WA is what? 25 kg into 9.81 will give you N1 value. Applying summation f of x equals to 0, right hand side taken positive, so plus t minus f1 equals to 0. F1 is mu into n1 equals to 0. T, we are aware that t value will be equivalent to this weight. Don't you think the t value will be equivalent to this weight? Hence 3.75 into 9.81, as it is also a kg. So 3.75 into 9.81 minus mu into N1. N1 is same as in the weight of the block. We have found 245.25. With that, we are getting mu equals to 0.15. This is the condition when it is a static condition. Now let's assume the dynamic condition. So for the dynamic condition, we'll just have a look. The dynamic equilibrium analysis, assuming whatever we got mu is mu s and mu k both. So mu k is 0.15. I'll draw the FBD of it. So as I told you that this is moving on a right side, if I'll take a dynamic condition, if it is moving on a right side, the acceleration of it will be on the right side. Acceleration of it is on the right side. And opposite to that, the inertial force, which is MA. What we have seen in our rules. So T is right side, MA is opposite to the motion, F1, which is frictional force, opposite to the motion, WA downward direction, N1 upward direction. Now if I am applying a summation f of y equals to 0 upward direction taken positive, so in that case minus W plus N1 equals to 0, N1 we got to this, the same what we have done above. Now summation f of x equals to 0, right hand side taken positive, so here T minus F1 minus MA equals to 0. T minus F1 minus MA equals to 0. T equals to F1 is mu into N1, MA goes on the right side, become positive. T equals to mu is what? 0.15, N1 is what? 245 plus M is 25 kg. It's 25 kg, that's why only 25, and A mentioned. So T, we got this equation. If you are having a thought that why we are not putting this T value 3.75, that was for the static condition. This is for the dynamic condition. This is the equation what we are getting. T is equals to in the terms of A. That is equation 1. Let's see the another block. FBD of block B. So FBD of block B, if you will see, there is a weight acting downward direction, tension acting upward direction. We have considered here that the acceleration is downward. The motion is happening downward. So WB down, T above. If motion is down, the inertial force will be opposite to the motion. So MA is above. Now here in the last section of the problem, if an additional 1.25 kg is added to 3.75 kg. So if I'm adding it 3.75 plus 1.25, I'm getting 5 kg. So summation f of phi equals to 0 upward direction minus WB plus T plus MA equals to 0. So here T is equals to WB is 5 into 9.81 minus, these all will be moving on the right side, so minus M is 5 into A. What is an A? A is an acceleration with which it is moving. Now this is equation 2. Equation 2 and equation 1. If I'll relate it, I'll be getting A equals to 0.409 meter per second square, and I'll substitute that A in any of the equation. I'll be getting T, which is 47.005. With this, I hope you understood the question. Thank you.